Math. Just the sound of the word makes me feel like it's a giant bigger than all others. Math, that looming voice that whispers inside our ears that we are failing and it's not working for our child. They're not learning it right. Well, if anyone knows me well, they know that I have tried pretty much every math curriculum available. Not all of it, but a bunch of it. So I do have some thoughts on this subject, and I wanted to talk to you about what's the first thing that you should consider when you're undertaking the math stuff with your children. Well, just like we had talked about with phonics and reading, and we need to apply this as well to math, is the concrete versus abstract thinking. So our children before the age of 12 are thinking in concrete terms only. So whatever they can see and touch, feel, this is what they can understand. And then in the preteen years, junior high, heading up to that age 12 and up, then the abstract thinking starts to kick in and they're able to start connecting some dots and pulling information from this place, applying it to this place, and it starts to kind of connect and make sense to them. So this is a huge factor that needs to be considered when you embark on which math curriculum and what your expectations of your child are in this area. I know a lot of us feel pressure from what we consider a plumb line maybe of what the public school is supposed to be achieving in grade 1, grade 2, grade 3. So I want to challenge your thinking a little bit, and let's look at really what our children need and when they need it and why they need it. So the Tom Lowe from the University of Warwick stated this beautifully. He said, in accordance with math, concrete is some apples. Abstract is 1, 2, 3 apples. Concrete is designing the pyramids in Egypt. The abstract concept behind it is trigonometry. The concrete concept is measuring positions, velocities, and accelerations of falling balls. The abstract concept would be calculus. So we are using abstract concepts to deal with concrete things. Our kids have this concrete thinking mind, and that is why math curriculums are great, and they use manipulative stuff that they can hold and touch and see. You know, here's the 100. Here we can stack 10 hundreds so we can get 1,000. You know, for our littles, you know, we can have our little counters and they can hold them and touch them and feel the different textures of all of what they're learning. So they're applying that concrete to this abstract thought of counting and place value. So math is a two-sided coin. On one hand, we have the math 4 operations: addition, subtraction, multiplication, and division. And all within these 4, we have all of our math facts that need to be memorized. On the other side of the coin, to build on those 4 operations, we have to know the place value and fractions and story problems and applying it to all of these real life situations. In math, there are so many abstract concepts. I'm not sure if it's all abstract, but it sure feels like it. So this child has to take what they've learned and they have to apply it randomly to different things in different times. Can you imagine the panic in a little child's mind if this is what is being expected of them before they're developmentally able? So we cannot expect thinking from them until they're age 13 or older, and even every child does develop a little different at different ages, so in that age range, but we can expect that application. I have a funny story with our oldest child. We had started, we were using Matthew C, and we'd used it for several years. And every single day, Matthew C is great about doing review questions, and they usually would have one review question each day or so on geometry, like the perimeter of something or the area. So my oldest had been doing this for a long time, quite a while, from ages, I don't know, I'd say 8 to 12-ish. So when he was 12 or whatever, he started out and he was doing his math lesson, and he comes up to me and he says, "Mom, what is area?" And I was like, my initial reaction was, "Are you kidding me? Like, we've been doing area every single day in your review for like 4 or 5 years, and you don't know what it is." And so that was my first mistake, that reaction, because I didn't understand my child's brain development and the natural inclinations of that age. So with my wonderful experience at that moment, I decided, you don't even know area. This curriculum is a failure. We are selling it now. I grabbed all of the books and all of the DVDs and all of the manipulatives. I sat down at my computer and I posted it all and sold it. It was, a little bit, whatever. So then now I realized that he was just actually now seeing this because it had been repeating and we had been inputting that good information inside of him. He was actually now trying to apply it and understand it and go at it a little bit deeper. So it wasn't the curriculum. There was nothing wrong with what was happening with that curriculum at all. It was just that I had not experienced this change and shift in developmental stages, and so it was brand new to me. I didn't even know what it looked like, and so I misjudged. So my poor children, they had to switch math curriculums with me. I don't even remember where we went from there. But so what I'm trying to say is, in the elementary years, we're going to just be giving them those math facts. And the goal is mastery of those math facts in all 4 operations. And then as they continue to grow beyond that, they will then understand when to apply those math facts. David Quine of Cornerstone Curriculum, he wrote several things, one of which was Making Math Meaningful. And he talks about the concrete thinking at this stage. And he says, students at this level of cognitive development learn when they are actively involved with actual objects, actual events, or actual situations. Although children at this level can memorize abstract concepts, they don't really understand them. In fact, at this point, students can often create misunderstandings of any abstract ideas they're taught. They need learning experiences in which they are involved with concrete objects. So we're going to be inputting in those early years. We're going to just have them be memorizing and mastering these abstract concepts, and they're not going to understand them, and we don't need to expect that. And that is, again, another failure that I had done, was when I was teaching math to my oldest kids, and I thought at their young age, oh, this is why, we're doing this and that at that young age. Well, they didn't care, or, and they weren't capable of understanding that. So all of my energy could have been much better spent if I would have just met them where they were at in their learning development and totally just focused in on memorizing the facts and counting and that kind of thing, and skip counting. So as our children get older, then they kind of switch in their thinking to abstract, and then they can actually reason. In math, it's called the deductive reasoning. So it's being able to discern when they look at a problem. Which of the 4 operations can I use right now? So how should I order this in the correct order to solve the problem? And so if it's being able to look at this problem and be able to understand that this is the first thing, here's the next. Again, and this starts when it's about preteen, junior high years, and it starts to get really fun as we learn and see how these kids can put things together, and we're beyond that initial, we're just inputting stuff, and they're starting to process it and use it better. So I am going to be going through in different videos here of the different stages and how I worked with them after I figured out that they existed. and how we implemented memorizing the facts with songs and games and stuff. So stay tuned. I hope you'll like the video and subscribe.